Good evening, everyone. I'm starting with the topic of class 11th, relations and functions. The weightage of this chapter is not more, but at the same time, this chapter is very important. I cannot name any chapter in class 11th and in class 12th that in which the relation and functions are not used. Okay, so there are some prerequisites for this chapter. You should have knowledge about what is set, simple set theory, and what is a subset. Yeah, these are the two topics that you should know. Now, what is a relation? Okay, before that, there's a question like if I have a set, let us consider a set, capital A, which contains the elements 1, 2, and 3, right? Now, how many subsets can you make? Subset, how many subsets of A are possible? So there's a simple formula for that. If number of elements in A is n, then number of subsets of A is 2 to the power n, right? Now, so how many subsets would be there? It would be 2 to the power n. Here, my n is 3. That means I have 3 number of elements here. So number of subsets of capital A would be 2 to the power 3. That means number of subset of A equals to 2 to the power 3. That is 8. Okay. So 8 possible subsets are there. Okay. Let me just write. They're just 8. Okay. We can write. So let us see A1. What is a subset? You have to choose elements from this A. It can be one element, it can be any 2 elements, it can be any 3 elements, or even it can be no elements. So if you're choosing no element, that means you are not putting any element in the set. So it's an empty set. This is also a subset of A. Again, if you're choosing one element at a time, it could be 1, it could be 2, it could be 3. All these are subsets of A. It could be 1, 3, 1, 2, 2, 3. All are subset of A. It could be 3 at a time, and that will be 1, 2, 3. It is a subset. Okay. So with this knowledge of sets and subset, now we can move to relation. What is a relation? First term that we discuss here is Cartesian product. See, mathematics start with the natural numbers, like, right? So you first learn 1, 2, 3, you learn these numbers. Okay. After that, what you did is you performed some operations on the numbers. Like there is a collection, okay, and you have all the numbers sitting here, all the natural numbers are here. Like, of course, it is an infinite collection. Every natural number is there. But they are just sitting there, doing nothing. But when you have an operator inside it, so far you know only 4 operators: plus, minus, multiply, divide. So if you take any, let's say I am taking plus in this collection, something will happen. Plus is an operation. It is a binary operation, means you, if I'm saying that, okay, this is the number, you perform the addition. This makes no sense because addition needs 2 numbers. Okay. So it is binary operation. That's why the name binary. 2 numbers are required. So 1 plus 2 will give 3, 2 plus 3 will give 5, and so on. Right? So operations, there is a collection, and then you have an operator, it perform a operation. Similarly, in the set, here I have the collections of all the set. Like I have considered a set here 1, 2, 3. It could be some other set B, A, B. It could be like number of sets are here. Of course, this is also an infinite set. I am giving an operation. I'm introducing an operation within this collection that is called Cartesian product. The symbol is just as multiplication, but this time this is not just multiplication. This is not 2 into 3. This is multiplication of sets, which we don't call it like multiplication. We call it Cartesian product of two sets. So similar things are happening, but now you are out of the numbers. You have something big here. You have collection of sets. So far, you are always, in between numbers. Now we have some different collections. So how to multiply two sets, or how to perform Cartesian products between two sets? I'm considering two sets here, 1, 2, 3, and 2, A comma B. So A cross B would be, I'm writing the definition first. What is the definition? It would contain all x comma y. I'm telling you what this represents, such that x would be from the first set and y would be from the second set. What does it imply? The first element here will belong to A and the second element here will belong to B. Simple. Now, why I have written like these brackets? What do it represent? What do we call it? This is not a number. This is not a set, right? We use these brackets for sets, curly brackets, not this. So what is this? This is, we call it ordered set. Now, name suggests ordered set means ordering matters. If I'm writing a set 1, 2, 3, and if I'm writing a set 1, 3, 2, if I'm writing a set 2, 3, 1, they all are same. Because ordering doesn't matter. You can change the order of an element. You can just, put it here or to here or in any position. Ordering doesn't matter. But in ordered pair, the name suggests ordering matters. So in the first position, you have to write the elements of A. In the second position, you have to write the elements of B. So when I'm performing the multiplication of two sets, that means Cartesian product of two sets, 1, 2, 3, cross A comma B. See, this set contains numbers. This set contains alphabets. But Cartesian product always contain ordered pairs. Always. Ordered pairs. First is from A, so let it be 1. Okay. Second element would be from B. So here I can choose A, I can choose B. So it would be A comma 1, A comma B. Then 2 comma A, 2 comma B. 3 comma A, 3 comma B. Right. So C comma B, that's it. Right? This is the Cartesian product. Now clearly, you calculate B cross A here. What would be B Cartesian product A? It would be A comma B cross 1, 2, 3. Now the first element would be from B. So from here. And the second would be from the A. That means from here. You can choose 2 or 3, right? The only thing that matters here is the first component should belong to this set and the second component should belong to this set. This is the only definition that you have to take care of. P1, P2, and B3. Right? Now, can you tell me A comma A and, 1 comma A and A comma 1? Are they equal? Just think about it. When I have defined this structure, when I'm using this bracket, I'm putting a comma here, I'm writing something here, I'm writing something here, the whole structure, I call it ordered pair, which means ordering matters. That means clearly if I change the order, this whole structure will change. So A comma A is not equal to 1 comma A. In fact, any element from this set does not appear here, or any element from this does not appear here. So a very common line, we call it like, it is so usually we call like 2 into 3 is 3 into 2. We know 2 into 3 is 2 into 3, right? Means commutative holds. Multiplication is commutative. But here you have an example that multiplication is not always commutative. Multiplicative is commutative when we are in numbers. When we are dealing with numbers. But that's not the case when we are out of we are out of our collection of numbers. Now, where are we? We are having the collections of sets, and we are performing Cartesian product in sets, right? So here A cross B is not equal to B cross A. So the Cartesian product are not commutative. Okay. Okay. So there's a set A comma B, A cross B. I have just written it here. A comma A, 1 comma A, 1 comma B, 2 comma A, 2 comma B, 3 comma A, and 3 comma B. Now my question is, can you find the subset of A cross B? Subset of A cross B. Again, subset means it's your choice. Without any restriction, you can choose any number of elements from this set and you can put it in set. That will become the subset of A cross B, and we denote it with this symbol. Okay. So let's say I'm choosing, let's say 2 elements, and this is my choice. So 2 comma A and 3 comma A. This is a subset, right? You could have chosen like 3 elements, any 3 elements. You could have chosen nothing. You could have chosen all the 6 elements, right? It's totally up to you. That is the definition of subset, right? Again, my question is, how many subsets? I have just written the formula here. If the number of elements in A is n, then there is the number of elements in A is 2 to the power n, which means here the number of elements in A cross B. Now count the number of elements. Please don't keep in mind that this is 1 element, okay? This is not 2 element. This is just 1 element. So this is 1. So total are 6 elements. The number of the subsets. Number of subset of A cross B is 2 to the power 6, right? Okay, so here this would be 64. Now I can't write all the 64. Definitely this is one of them. Definitely this is one of them. Means, let's say I have 64 students, right? I have total 64 students. And I told each of them to choose any number of elements they can from this, and they have the right to choose nothing. They have the right to choose everything. They have the right to choose any one of them, any 2 of them, any 3 of them, and so on. So it is possible for every 64 students to create a unique set of their own. Just think it through. I'm saying total number of subsets are 64. That means if I am giving 64 students a job of choosing the numbers from here, means there is a possibility that every student among those 64 is choosing, they have their own unique subset. Means the subset that they have made doesn't match with any of the other 63 students. Okay. So what is the use of everything? That is coming in my next definition, that is relation. From relation, we'll move on to functions. Functions, the topic of function is not taught very, very seriously because of the marks. It doesn't have much weightage. But without functions, if you are studying mathematics without knowing the actual knowledge of relation and functions, I think there is no use. No use. You will not be able to crack any exam if you are not taking seriously this chapter. So coming back here, relation. Relation, I'll write a simple definition. Okay. Relation is always from a set A to a set B, I'm not writing A cannot be empty because A can be here. Okay. So relation from A to B. So relation from A to B is nothing but a subset of A cross B. That's it. I'm giving a special name to these subsets. Relation. That means if I'm saying every student to make a subset of, like, I have again 64 students and I'm giving the job to every student that you have to choose number of elements, whatever you want. Okay. That is equivalent of saying you make relation from A to B. So what they have in their hand is actually the subset of A cross B, which is also relation from A cross B. So they are the same. Okay. So what I have written here is actually a relation. So 2 comma A, comma 3 comma A is subset of A cross B. And the definition implies that this is a relation from A to B. Different representation of functions, of relation. Okay. Now I can represent it with, so I'll discuss every possible representation. We'll be using a different representation in different questions. Like in some questions, some representations will help, and in some questions, that representations will not be even possible to write. Okay, so we need to know every representation of the relation. When I am saying representation, means it's just a different way to write it. Means I'm going to write this in a different way. It doesn't change the definition. The definition is same, subset of A cross B. So if I'm writing, so this is one way of writing the relation. The relation is 2 comma A, 3 comma A. This is one way of representation. This will be roster form. I said this R is for relation, not the roster form. This is roster form. Okay. So what we do in roster form, we just pick the elements and we just write it. Okay. This is the way. Now, there is a way when I have to define it, like all the x comma y such that what is it satisfying? X belongs to A. This is the relation from A to B. X belongs to A. X is not equal to 1 because I have 3 options here. Let me write just A and B again here. A is 1, 2, 3. And B is A comma B, right? Okay. So X is not equal to 1. That means X can be 2 and X can be 3. Here I have written. And then Y belongs to B and Y equals to A. Means only one option from B and there are 2 options from capital A. So basically what I'm trying to do is, instead of actually writing the elements here, I'm writing some property. I'm observing some properties like, the first element is not 1. So I'm writing X first element is not 1. You can write it in any way, but no ambiguity should be left. Means your description should be complete. Nothing should be left. Let's say if I would have written XY and X belongs to A, Y belongs to B, and X is not equal to 1. So here there is a confusion. You are saying X is not equal to 1, which means X can be 2, X can be 3. But what about the option Y? You are saying Y belongs to B, means Y can be A, Y can be B. So I can write A here, I can write B here, or I can write like B with 2, or I can write A with A. All the 4 are possible according to your description, which is not my this set. So this description is incomplete. Okay. So make sure whenever you're writing the properties, you're mentioning the properties of your element in the set, it should be complete. Okay. This form is, we know, we call it as set builder form. Now the last one, which is quietly, it is liked by everyone. It is like you draw A here, you write all the elements A like that. You draw B here, you write all the elements of B here. And it's a relation. That means elements of A is related to element of B. This is an intuitive idea. Okay. So this is called arrow diagram. So which means you have to draw arrow here. See, 2 is related to A. So from 2, you draw an arrow toward A. And then 3 is related to A. So from 2, you draw an arrow over here. That's it. This is the arrow diagram, which is the simplest one, where you can see that 2 is related to A, 3 is related to A. Again, I'm saying different representation doesn't change the actual definition of the relation. Actual definition of the relation, you always have to remember this is a subset of A cross B. Going through all the end of the when we will go toward the end of the chapter, most of the students actually forget what was relation. Please don't do that. Okay, revise this whole chapter is more of a like theory, not the calculative portion is not here. So and to make your grip on this chapter, all you need to do is consistency of the revision. Revise it. All the things are very new because you are coming out of your comfort zone. When I'm saying multiplication, can you say multiplication is commutative? It immediately stuck your mind and it says yes, it is. But you have to now come out of those numbers. You have to think beyond the numbers. There is so much thing beyond the numbers. We will add some structures that you have never seen. I have multiplied 2 structures that you have never seen. That means basically I'm changing the definition of multiplication. Okay. So these are the theory parts, and you have to make your mind to, think out of the box. And that will only happen if you give the continued revision to this. Okay. So I'm ending it here. After this, we have, types of relation, then we'll move to the functions, then we have types of functions. But let me tell you, everything is easy if you are consistent. Okay. So we'll meet in the next class. Thank you so much.